All right, so let's now have a formal definition of what it means by being a limit to a function as x gets closer to a limit point a right here. So this definition is a quite standard definition being written in many textbooks out there. So the definition say, in the definition it says, we say that the limit of f of x equals L as x gets closer to a, and formally speaking written as lim, the symbol lim, lim of f of x equals L when x is allowed it to get close to a right here. So this is a symbol. Okay. So that, when we say that, it means if we can make values of the function f of x arbitrarily close to L, meaning however close we would like to be, we can make it. So we can make our function outputs to be as close as we like to L by simply taking x to be sufficiently close to a in either side of a. So this statement in either side of a was the reason why I was tearing it down to two separate table of values. One table of value was describing x getting close to 2 from the left hand side, and the other table of values was describing x getting closer to 2 from the right hand side. And I emphasize again that but we will never let x equals a. So think back into our problem, we will never substitute x equals 2 into our function 2x minus 3. And so after looking at the definition here, it's now time to look at some good example. We can start doing some example, and we will start getting into that routine of how to solve and how to find limits here. So allow me to introduce example 1 here. So in example 1, let's look at, so I'm going to start out introducing example 1 as, let's say we want to evaluate, okay, and our first function here is the function x squared. So you can think about f of x equals x squared. And so on this function, I want to allow x, I want to find the limits of this function by, as we let x get close to -1. Okay. And so I have to clarify notation a little bit, but -1 is the value on the x-axis. We got -1 and 0 and 1 in the integers value among the integer values. But this is different with 1 and a superscript. So in the limits concept, x gets close to 1 and a superscript minus sign right here. This is x getting close to 1 from the left hand side. But in our problem, what it says here is that if you're looking at this limit line, x is getting close to -1, but there was actually no superscript. So indicating that here we would like to find, and we just want to get straight to the point of, hey, if we let x gets close to -1, but from both sides right here. So if we're letting x get close to -1 as our limit point, so this is the limit point again. So here's our destination, our limit point. So now we want to consider, hey, what happened to the function value of x squared here as we let x come close to -1. But we have to cautiously consider as x gets close to -1, but generally from both sides. Okay, so I repeated my wording for a couple times right here. Let's get it done. And so that means with this instruction right here, we are required to tear our function into two separate tables, to put our work into two separate works right here. So on one work I'm doing, and here I'm going to consider how about left hand side. So you have seen me using this notation before, but LHS here, I've learned this from a few other instructors out there, but LHS stands for let's consider the left hand side table of values. So describing x, to describe x get closer to -1, how about I'm going to start out with -2. Well, -2 is somewhere to the left hand side of -1. And So, or how about before I rush into the next value, let me quickly demonstrate that through the line of numbers again. So on the line of number, okay, -1 is somewhere. So I chose -2 here. So -2 from at start right now, it's from the left-hand side of my table. I mean the left-hand side of my destination point. So this is our limit point, the destination. This is our limit point. Okay, or you can think of that as a destination. So values of x are getting closer to this destination. So on my back on my other board right there, continuing with my table of values. So to get closer to -1, but still maintaining on the left-hand side of -1, I'm going to choose, how about -1.1. And then in that way, I can choose -1.01. And I can choose the next one being -1.0001. And how about one further value right here, -1.0001. Okay, and so now we are ready for calculation. And I highly recommend that anyone viewing this video at this point now, go ahead and pull out your own calculator, whichever kind you have for your calculator, but plug in these values into your function, f of x equals x squared, and then get your function output value filled into these entries on the table. All right, so assuming you do your own work too, you can double check with me. But my own table of values show me that the function output is 4 when x equals correspondingly -2, and then continuing to fill in my table here, -1.1 substituted into the function give me positive 1.21, and when -1.01 substituted into the function or plugged into the function, we're looking at positive 1.0201. Now, allow me to correct my writing a little bit here. 0.0201, and then -1.001 substituted into the function. We're looking at output being 1.00201. Okay, and then the last one in our table over here was positive 1.0002001 right here. So now we are ready for a little bit a half-sided, one single-sided, left-hand-sided conclusion here. But our function x squared, as we are allowed at x, as x gets closer to -1, but the table here was describing from the left-hand side. So here I introduced, so we did this work. We have to find our left-hand side limits on purpose right here. So as we are allowed at x gets close to our destination -1 from the left-hand side, then the prediction here, you can pause the video and go ahead and make a prediction. So prediction here should be, I predict that, and hopefully it agrees with yours, that the output function of x squared here, as we let x get close to -1 from the left-hand side, comes to 1. So we found the left-hand sided limit. And so once again, that table we just did took care of the work where we allowed x value gets closer to -1 from the left-hand side. And now, what about when we get closer to -1 from the right-hand side? Because remind yourself that this work in the beginning, the problem wanted us to find the limits of this function x squared when x gets close to -1, but generally from both sides. And so now it is our responsibility here to really do a separate work. So far we have only found half of the problem. So let's look at the other half. And as you have seen on my line of real numbers, now we are trying to approach the destination from the right-hand side. So I am now going to produce a table of values as following. But notice my aim here, my intention here is going with RHS, right hand side. But so our function output is being listed on the right hand side column. So how about a good starting point here to be from the right hand side of x equals -1 here is going to be, how about 0? Okay, and then after 0 I am going to go with -0.9. Then I'm going to jump to -0.99. Then I'm going to jump to -0.999. And how about one more entry? How about -0.9999? All right, so I am going to spend a minute doing the calculation. I highly recommend that you do your own calculation, and we are going to compare answers as I come back here after my own calculation. All right, so hopefully you had your own calculation, and my own calculation hopefully agrees with yours here. But when x equals 0, we purposely chose a value being to the right hand side of -1. Output's value came out being 0. Easy enough to understand. 0 squared is 0. Now -0.9 substituted into the function. Now be careful with operation order for here. So make sure you square the entire 0.9 including the signs here. That's just a brief algebraic reminder, but that's not our main aim of the problem here. Final outputs for this came out to be 0.81. Let me correct my writing a little bit here. So 0.81. And then when x was -0.99, our output value was 0.9801. And then here we're looking at 0.99801. And then for the last entry here, we're looking at 0.9998001 right here. Okay, so now after having, and of course I really hope that anyone who was doing the same calculation came out with the same answers to agree with me in terms of the outputs for this function on these corresponding inputs. And so what's your prediction? My prediction here, it looks to me like as I was allowing my x value to get close to -1, but this time from the right hand side. So notice how I use my superscript plus sign. The destination point, the limit point is -1 on the lineup number, but we're getting close to -1 from the right hand side. That's the entire idea of using the symbolic superscript plus sign or negative signs here. And our function is x squared. So again, as we let our x values get close to -1 from the right hand side, then this function x squared here comes to a limit, and that limit there we predicted. That's why I put equal sign here. Come to limit 1 as well. All right, so this is the right hand side limit. So now allow me to jump to the other board a little bit here. But so erase part of the writing on the board, and I'm going to keep the lineup numbers here. But left hand side, as we're considering x value getting close to -1 from the left hand side, then our function came to that limit being 1. And then on the right hand side behavior, as we were letting our limits, our x value getting close to -1, but from the right hand side, then our function also came to the limit 1. So left-sided limits and right-hand-sided limits both agreed. So now we are ready. Let me get back to my other board there. We are ready to make our ultimate answer. Because keep in mind again, this question right from the beginning did not ask for particularly a left-hand side limit or particularly a right-hand side limit. That was our responsibility to tear the problem down to two separate sided limits. But here our final conclusion is, as x gets close to -1 generally from both sides, then this function comes to limit that is equals 1. Okay, and so we found the answer to this problem. All right, and now allow me to call that work we just answered. How about part A of our example 1? Because I would like to produce the next example. We are in the same class of example in a sense that it's all about we're evaluating limits. But how about I'm going to give in part B a different function so that everybody has more opportunities to practice along the way. And I'm also still going to be showing it on the board here. So everything we did there finished at this point is considered as part A of our example 1. All right, so here we go at part B. So part B here, let's look at, we're given a function 2x squared plus 1. So now our function involves more term here. And we are asked to find the limit of this function as we allow x get close to 0. Okay, so 0 is the limit point on the x-axis, and we want to find out, and once again, no special superscript here indicating that we must do the work where we're describing getting close to 0 from the left-hand side and also getting close to 0 from the right-hand side. So this problem is we have to find out what's the answer, what's the limit of this function when x generally gets close to 0 from both sides. Okay, so now at this point, after seeing quite a few problems, then we can start speeding up the process a little bit. But how about for the left-hand side? I am going to produce a table of values again. So x column, output column. So left-hand side, on the left-hand side of 0, let's say we can start with -1 for x and get closer to 0. How about -0.5, and then -0.25, and then -0.125. All right, so again, how about -1, -0.5, -0.25, -0.125, and -0.0625. So I put in that last value here to maintain about 5 value entries on my table. Let's get back to my other board so that I can once again describe graphically how these values are behaving. So on the line of real numbers, this time 0 is here, and according to my chart, my table, I was starting out with x equals -1, then -0.5 is here, then -0.25 is here, and -0.125 is here. So every single time we jump by a half distance. But how I choose the values, you can have your own choice of your own way of choosing the values too, as long as these values together create the idea, create a sequence of x values that are getting closer and closer to our destination point, our limit point here, being 0 in this problem. And so the other value is another, how about right here is about right there, -0.0625 right there. So we're getting close to 0 from the left-hand side. All right, so for our table of values here. So let's start out with our calculation. So I want everybody or anyone viewing this video, go ahead and spend your own time doing the evaluation again. And then I'm going to get back with you with these output value filled in. All right, so now hopefully you had your own calculation. So my calculation showed, so when x equals -1, then correspondingly my output value was +1. By the way, I had a little bit of miscalculation here. But here it's actually +3. All right, so after correcting my calculation, so the value I've had here was, so this is a 1.5 right here, right? And our next value here is a 1.125, and our next value down was 1.03125, and last value here on the output list is 0.0078125. Okay, and so now I'm ready for making a prediction. Okay, so I predict that as our x value is getting closer to 0, but from the left hand side, and in the meanwhile y value is coming closer to my prediction, y equals 1. So 2x squared plus 1, this function here has limit now as x coming close to 0 from the left hand side. So the question did not ask us to do this, but we, under our responsibility, must be able to tear it down to a left-sided limit and later on perform with a right-hand sided limit. So currently we're about finishing with our left-hand sided limit. So once again, as x is getting close to 0 from the left-hand side, this function 2x squared plus 1 comes to a limit, being my prediction here is 1. And hopefully it agrees with everybody else's answer. So, and now I am going to erase this work and ready for another work right here. And so on the other hand, let's now create the right-hand side table. And the table should look similar. There's an x column on the left-hand side. There's the function output value on the right-hand side. This time being to the right-hand side of 0, how about I'm going to choose a 1 for start. And then I'm going to jump down to 0.5, positive 0.5. How's that? And then positive 0.25. And then I'm looking at positive 0.125, and even closer, positive 0.0625. Okay, and then so once again, you can go ahead and start doing your calculation. In the meanwhile, allow me to switch back on my other board and do another graphical illustration. But 0 is our destination right here. Okay, then this time we want to choose how about positive 1 here. And then we are now getting closer to 0 from the right-hand side. So 1 was already closing up, but how about I even want to go closer? So 0.5 here is a lot closer to 0 compared to 1. And next one on my list was 0.25. So 0.25 is right here. 0.025. I mean 0.25. And then the next one here is a 0.125. So I have a 0.125 right here, even closer to 1. I mean, even closer to 0 compared to 0.25. And then here is my value. That's about 0.0625 right there. All right. And so again, back to the calculation on the table. Hopefully anyone who viewed this video already had your own calculation. But these output value, when x equals 1, function output is 3. When x is 0.5, function output is 1.5. And when x, and then we're looking at 1.125 here. We're looking at another positive value, but 1.03125, and you can see that these values are getting smaller and smaller. And then the next one here, correspondingly to 0.0625, then we're looking at my next one down the list, 0.0078125. Okay, so this time let's observe our prediction here. But so observing these values for the y value, then once again, right hand side table, as we letting x gets close to 0 from the right hand side this time, then our function comes to a limit. So our function is being 2x squared plus 1. Now, this function comes to the limit x come to 0 from the right hand side. And so what is your prediction? You can go ahead and pause the video and make your own prediction. All right, so after you've had your own prediction, I predict, hopefully that agrees with yours, that limits on the right hand side as x getting close to 0 from the right hand side. This function also comes to the limit equals 1 as well. Okay, so after all that work here, now again, let me erase all of these individual works. So our ultimate question in the beginning, I want to find, so left hand sided 2x squared plus 1 came to the limit equals 1 as we let x comes close to 0, but from the left hand side. On the right hand side table that we have seen earlier, same function, 2x squared plus 1 came to limits equals 1 as we let it x comes close to 0, but from the right hand side. Okay, so the left hand side and the right hand side limits both agree on the function output value to come to the same limit value for the y value. So now our final conclusion here, this function 2x squared plus 1 come to limits generally 1 as x came close to 0 from generally both directions. So once again we found our answer.